Okay, then here's the question. I've got it summarized here. So let's have a go at it then. Find dy dx first of all. We need dx dt and dy dt. So dx dt then. E to the something differentiates to e to the something, multiplied by the something differentiated. Differentiates to minus 2, so we'll get minus 16 e to the minus 2t coming out from that, and the constant differentiates to 0. Dy dt then. E to the something differentiates to e to the something, multiplied by the something differentiated, which is 2. There's a 2 already there. 2 2's are 4 lots of then, and the constant goes to 0. So, dy dx is equal to this divided by this, over the minus 16 e to the minus 2t. So it's minus 1/4. This e to the minus 2t can come up to be e to the 2t on top. Times you add the powers, 2t and 2t make 4t. So that's part A. Point P is on the curve. So B, t equals ln 2. Part 1, find the gradient at P. Minus 1/4. E to the 4 ln 2 then is the time. Put that in here for the dy dx value, which is a gradient function, minus 1/4. Now the 4 is in the way of the e and the log cancelling each other out, so the 4 comes up here, and 2 to the 4 is 16, using the properties of logs. Now these two will cancel, we'll just leave 16 over 4, which is minus 4. So the gradient at P is done. Find the coordinates of P. So x is equal to then, and y is equal to at P. 8e to the minus 2t minus 4. E to the minus 2 ln 2 minus 4. The minus 2 comes up. 2 to the minus 2 is ln of 1/4, isn't it? When we move that up, minus 4. So it's 8 times 1/4 minus 4, which equals 2 minus 4 is minus 2. So there's x. Y is equal to 2e to the 2t plus 4. There's the value of t put in, plus 4, which equals 2e to the ln. Properties of logs, 2 squared is 4, plus 4. E to the log can now cancel each other out because they're adjacent. So that becomes the value 4. 2 4s are 8, 8 plus 4 is 12. Okay, so that's 12. So that was part 1. Coordinates of P are minus 2 and 12. Part 3. Let's have a look at that then. The normal at P crosses the x-axis at Q, find Q. So the normal at P, y minus the y value, at P is 12, is equal to the normal. The gradient is minus 4, so the normal will be a gradient quarter. X minus the x value at P, which is minus 2. So what does that tell us then? Move the 4 up. 4 lots of this stuff. 4y minus 48 is equal to x plus 2. So that tells us then that, oh, we could just leave it like that, couldn't we? Y is equal to 1/4 x. Move the 12 over to plus. 2 over 4 is a half. Plus 12 is 25 over 2. And that's the equation of the normal. Okay, and it crosses the x-axis, so when does y equal 0? So y equals 0, here means that x will equal, move the 2 over, minus 2 minus 48 is minus 50. So Q has coordinates then minus 50 and 0. Good. That's good news. The Cartesian equation now then of the curve. Find the Cartesian equation. Okay, this is part C then, separate part. Okay, well here's x. So x is equal to 8 over e to the 2t, isn't it? Minus 4 from there. Y is equal to 2e to the 2t plus 4. So let's move this 4 over. X plus 4 is equal to 8 over e to the 2t. And then we can move the e to the 2t up. And that's equal to 8 over the x plus 4. Move that down. And we can sub that in there. So that's 1, that's 2. So sub 2 in 1. We get y is equal to 2 lots of e to the 2t is 8 over x plus 4. X, or y equals 2 of this plus 4. So move the 4 over. Y minus 4, move that over there, is equal to 16 over x plus 4. So what have we got then? Y minus 4 times x plus 4 is equal to, move that up, 16. xy plus 4y minus 4x minus the 16 when you expand the bracket here equals 16. So let's just check that. Xy plus 4y minus 4x minus 16. So that tells us then that xy plus 4y minus 4x is equal to, move the 16 over to become 32. Let's check that then. Plus 4y minus 4x plus 4y minus 4x equals k. So k is equal to 32. Done.